Hello, Christopher. Today I'm going to talk to you about something that seems like it all comes together in the end and makes sense, which I feel like there's not very many things like that in life. A lot of things in life are very confusing, but this, I think, makes sense. So I'll try to explain it to you. Anyway, the topic today will be logarithms. The question comes, what is the inverse of taking the exponent of something? And you might say, well, it's the square root. But it's not, because you've got this one case, if this is the problem you're trying to solve for y, you take the square root. But if this is the problem, you're not going to solve by taking the yth root of x, which is what you would do otherwise. You're going to change it to a logarithm so that you get it solved for y. So basically both of these are equivalent ways to take the inverse of an exponent. So basically in math you've got just a polynomial type of function. You got this one, which is a root function. The logarithm function, exponential function. There's actually a third type, and that set is the x root type and the base x logarithm type. So the difference between these 6 scenarios is just which value is the exponent versus which is the base and which is the power. It all comes together in the end. Over here I have the ultimate formula of how these relate to each other, and it's a beautiful triangular formula here. Everyone knows this matches with this, because this is the definition of a logarithm. 5 times 5 times 5 is 125. This is not writing very well. Log base 5 of 125 is also going to equal 3. Anyway, you got 5 to the third equals 125. That's s to the t equals r. And then everyone knows this as well, which you use all the time to get like the square root of a number. So if you want to move the t over here, you just take the tth root. But this is also equivalent. So you can transform directly from a logarithm to a root function, or from a root function to a logarithm function, by replacing the appropriate variables. So yeah, that's what I have for you today, basically. In regular mathematics, you've got simple operators that are symbols that are stuck between stuff to get stuff. Here, you've got a superscript, a weird symbol, and a function name. It doesn't make sense. So I have invented this own little code that I've almost completely invented myself, except for this one, because it already exists and is pretty well used. But here I have this symbol, which I'm using for root, and here I have this symbol, which I'm using for logarithm, and I'm keeping the order the same, so it's the base and then the power. So likewise, these work if 2 is the base or if 2 is the power. So there you go. Yeah, so anyway, so if in other words, if it's a constant base. So here you've got the same set of equivalent equations where you've got r equals s to the t, base s logarithm of r is t, and then the tth root of r is s. So you have to remember that in each of these cases r is the big one, the power, and so that's how you use them. But yeah, this would make so much more sense if all mathematicians did it this way, but of course they don't.